Alright guys, so we're going to be solving exponentials with common bases today. The key to solving these is making sure that the bases are always the same. The base is the number down here, so we're just going to make sure that these are always the same. We're going to set the exponents equal. The exponents are what's in the corner, and then we're just going to solve the equations from there. So the first thing we have to do, we have 8 in our bases here. The bases are the same, so that tells us that we can set our exponents equal to each other. So for this one, all we're going to do, since we both have 8's down here, we're just going to take 2x minus 5 and set it equal to this exponent, which is 6x plus 7 is equal to 6x plus 7. Okay? So now all we're going to do is we have to solve for x at this point. So we're going to do 7 plus 5, so that's 12. So we're going to have 2x equals 6x plus 12. I'm going to take 2x from this side, so we're going to have to do 0 equals 4x plus 12. And I'm going to go ahead and move negative 12 over. So we're going to have negative 12 equals 4x. So x should be equal to negative 3 for this one. So guys, this is my answer for this. So to recap, all we did is we made sure that the base is the same. We set the exponents equal to each other. And we just solve for the variable. All right. In this next example, we have 2 in the base here and we have 16 here. So they're not the same. So we're going to try and rewrite this 16 so that it has the same base of 2. We need to make sure that they have the same bases. So I'm going to leave this side alone for now. So I'm going to have 2 to the 5x plus 3. I'm going to leave the equal sign. And we're going to take this 16, and I'm going to write 16 as 2 to the 4th, since 2 to the 4th power is 16. So 2 to the 4th, and 2x minus 1. My exponent rules tell me that I can multiply the 2x minus 1 times this 4. So I'm going to bring the line down again. So we're going to have 2 to the 5x plus 3 is equal to, remember we have to distribute this 4 to the 2x and to the negative 1. So I'm going to have 2 to the 8x minus 4. Now we have the same bases. So here we have a base of 2, here we have a base of 2, and it's just like the last problem. So we're going to bring down our exponents and set them equal and solve for the variable. So at this point, I just have 5x plus 3 is equal to 8x minus 4. Okay? Now I'm going to just add 4 to both sides. So add 4, 5x plus 7 is equal to 8x. Then we're going to take away 5 from both sides. So I'm going to have 7 is equal to 3x. And then we're just going to get x is equal to 7/3 if we solve for x. Again, same base, set the exponents equal to each other, solve for the variable. So x equals 7/3. Alright, last problem we're going to do, guys. Here we have a base of 25, and here we have one of 25, or of 125. So we have to think of a number that we can raise to the exponent so that it's going to be the same base. So for this one, let's go ahead and try 5 for this one. So I'm going to rewrite 25 as 5 squared. And it still has that exponent of x to plus 4. And I want to have the same number here that I do on this side. So I'm going to write this one as 5 to the 3rd power, because 5 to the 3rd power is 125. And we're going to keep the exponent of 3x. Again, same as the last one, we're going to take our exponents and multiply, because that's what our exponent rules tell us we can do. So I'm going to have 5 to the power 2x plus 8 is equal to 5 to the power 9x, because 3 times 3x is 9x. Okay. Lastly, our bases are the same again, so we have 5 and 5. So I'm just going to set the exponents equal to each other. So we're going to have 2x plus 8 equals 9x. Subtract 2x from each side, we get 8 is equal to 7x. And last, we're just going to take x is equal to 8 over 7. And that's going to give us our final answer.